to be a quick little update to the video that I put out already. I got done video editing the whole thing, so I'm just going to combine these two clips into one. But I reached out to Dynatron and I'd asked, hey, these, your K-21 and your K666 cooler, these things are virtually identical from what I can tell. And they replied back with, yes, they are in fact identical. The only difference between them is going to be the fan speed. So I did some more digging, and I've discovered that Alienware on the PWM, it doesn't send a signal past 4,500 RPM. So, granted, I haven't tested that. I don't want to repaste everything and try out the other one. But it kind of corroborates what I'm seeing here, in that the old one, being a 5,000 RPM cap, probably was also never getting fully utilized. So, I've been through a lot of stuff. I've tried for the past day to get this Corsair to work. This is the the H60. This is supposed to be able to plug right into the top of the Alienware. Didn't have any luck. I've tried for many hours, all different kinds of configurations, and long story short is the bottom piece right here, the distance from the screw hole here to the top of this the return line, it's too big, and so the bracket that it's supposed to sit into, it interferes and it's pushing screw holes out of alignment. Also, the width on here is too wide to actually fit into the little cage. If you have one of these Alienwares, if you ripped it apart, you'll know exactly what I'm talking about with that. So that piece didn't work. I've also got a CryoRig low-profile cooler on its way. I've got a Dynatron low-profile like ITX-1U cooler on its way. I've also bought a Noctua fan to replace on, we'll just grab the K666 here. So I was trying to work within the bounds of what Alienware allows, and so I found this is just going to be a 60mm fan right here. So I found a Noctua one that's supposed to cap out at 4,000 RPM, and it's supposed to move around 30-ish CFM. So I figure if this is supposed to move 25 at 5,000, the Noctua might actually be a little bit better. But then the third piece that I wanted to try was I was thinking, gosh, the machine is coupled to 4,500 RPM, so I'm never going to be able to use an 8,000 RPM fan that's in the Dynatron K-21. So I figured, what's the harm, right, in a manual speed controller? So the NA-FC1 from Noctua also, basically it's got a 4-pin in and a 4-pin out. And so I figured maybe I can override somehow. And so I've got it hooked up here, and I've been running some testing, and the results that I'm seeing are great. Those settings are getting the K-21 cooler up to around 8,500 RPM. I've been trying different profiles, different manual overclocks on the Alienware just to kind of dial it in a little bit. And with the i9 9900KF processor that I have on here, it's peaking up to around 190 watts. So I guess straight off the bat, that's not going to work. This cooler here is rated at 125 watts. The K666 was rated at 95 watts. So neither of these is going to be able to deal with that kind of thing. You're going to need a big liquid cooler, and I would argue that even a 120 millimeter AIO like this one is probably going to be a little bit small for that kind of wattage. You really should be using a 2-fan AIO for that kind of thing. But I made some other changes, and we'll walk through those in just a second. So this right here is going to be the Noctua NA-FC1, and so this is going to have a 4-pin cable connected to it and a SATA cable. So the SATA cable is going to be providing power. I've got this plugged into just a spare SATA slot. And then the other one is connected into the CPU fan. And so the green light here is going to indicate that the fan's never off, because this again adjusts it. You can press that button for never off. We probably should never be low enough that it turns off. But then this is going to be your potentiometer here, this little dial. And so we're going to keep it jacked. And so what is going to happen here is basically this thing is going to allow this to run at whatever RPM it wants. In this case, I'm seeing it up to 8,500 RPM. And then it's going to give that information back to the board. So it's kind of taking out the board as being the middleman here on actually dictating speed. The other change that we made that we can probably see right here is the fan used to sit right here, which was pretty close, but then you have this giant cavity here for that air to kind of turbulate, and you're going to end up with theoretically a little bit of buffeting, which you hear a lot if the fans get really fast. So I've taken the cage that was in here and I pushed the fan all the way there. So the fan is actually, whoops, it's on. The fan is actually pretty deep in here. So these two things combined, again, I haven't run Cinebench with this closed yet to create kind of like the wind tunnel, but based on this here, let's see if we can pan up to the screen. So I don't know if you can see it necessarily super great, but we're at 10,175. So again, Cinebench rating on this should probably be closer to a 13,000, so we're certainly low. We're going to chalk that up to the fact that we are running into thermal issues. This thing does get to 100°C now whenever it's going only for a brief second, and then the fan speed catches up, and then it's pulling it down to mid-90s to, I guess, high 80s on that. So we're a lot better now than just pegged at 100 like we were before. So now that we've kind of seen the inner workings here of this, I'm going to get this mounted presumably right to, this kind of area on the other side of this cage, or potentially on the power supply here. But I'm going to get this mounted out of the way, and then we're going to close it, and then we will run it again. But I guess I can't express how happy I am that I've been able to stay away from liquid cooling, find something that works, right? This VRM cooler right here throws off the opportunity for a lot of things. First off, it overhangs really far in this way, more so than a typical VRM cooler would. Overall, I mean, this thing certainly isn't built for, custom builders. This is very much you don't want to screw with your computer. And I guess I love to tinker. The only reason that I got this computer was because it was on a Dell outlet deal for, I think, $450, 2, maybe 3 years ago. And so for, $450 with, it had, I don't remember what RX card it had in it, and it came with an i5. And so, I mean, a copy of Windows, I think I flipped the graphics card for $100. I mean, that brought the cost of this effectively down to $350. I would argue that you can't actually build a computer with, an i5, 8th gen, and all the other gear for $350. So for me, that was a good deal at the time. I have been wanting to upgrade my daily driver for a while now, and I haven't really seen the need. I mean, this thing still does everything that I want. So, okay. So we've got our Cinebench here. As we can see, hopefully you can see that that's 10,175. We've got the computer here put back together. We've got this so we can just kind of monitor, but this is going to be mainly what we're looking at here. We peaked out last run that we did at 101. Let's see if we can reset this. So we'll look here at our CPU core temps. We're running 41-ish. We're 3% utilization, so we're good there. And then the other thing that we're going to want to look at is going to be our fan speed, which is right here. So as you can see across the board, our CPU now we're at around 1800. So we'll hit run here. Again, we're in Overclock 1, Overclock 2 on Alienware, and I've tried to do some customs, and honestly, they were just as good as Overclock 1. So for having one click, I just figured that that's probably easier. So we will be able to keep this here, so you can probably replicate on your own also using the same settings very easily. And we'll look at that. We'll likely see the this kind of lag behind our temperature a little bit as it catches up, but let's hit start on Cinebench and see what happens. So we're up to 100% utilization. We've gotten up to 91, 94, so it's tracking there. We're up to 2200 RPM, so not very high. And now we're starting to climb. Okay, so now we're up to 100°C. And you can hear the fan starting to kick in. Again, I would say these right now are a lot quieter than they ever have been. Just the fact that you don't have that buffeting noise. And you can hear the high-pitched squeal, I'm hoping you can, of that CPU cooler as we're holding to 99, 100. So again, we're in the turbo boost phase, so in a half a second here or something, we're going to see that drop down and it'll go into sustained, which is kind of what I want. And looking here, we're at 8,500, 8,600, so we're good there, and we're around 150 watts or so. 178 is what we peaked at. We're around 170 watts on our package. So hopefully that thermal throttle didn't necessarily kill our score totally, but we'll see what we've got here. And we got 1,878, so it's the best we've had. If I were to go in here and probably drop down the frequency just a tiny bit more, or give us a little bit of a lower voltage, we may be able to eke out, so we're not there. But you heard that was a sustained load, so we can hit one more time, and then maybe we don't have the turbo boost, so we'll figure out what it is in a non-turbo boost kind of scenario. So it looks like right off the bat we are back to 100C, dumping 160 watts in. Again, this is only a 125 watt TDP rated cooler. So when you're doing, 50% more than it's rated for, you're going to run into some thermal issues there. But now we've dropped it down, so now that it's kind of declocked itself, we're running around 90. It's still loud, right? Don't get me wrong. This isn't going to be, if you got your NZXT case or whatever with, a couple of 120 millimeter fans on the back, this is going to be quieter. An ITX fan that's, 90 millimeter probably is going to be quieter than our 60. But in the end, getting this to work thanks to that Noctua power modulator here has really, really saved the day. 10,527, so I think, clocked, I think it's really, there may have been some thermal mass built up there, I'm not sure. So, again, we've gone up, we're about 10% faster, we're running quieter, which is my big issue. Or I guess the big concern, the reason that I wanted to try this. Where many, many hundreds of dollars probably could have bought a new rig between all the coolers that I bought, planning on returning the Corsair as, it's still, thermal paste hasn't even been touched yet on it, so that's still in a resellable condition. And then probably whenever I might try some of the ITX coolers, I might not. We'll track how good this video does. If I'm not sure if people are still looking at trying to mod these and if there's really a market. But I wanted to give a big shout out to Noctua for, first off, being innovative enough to build stuff like this to actually help the customers out, and some of these really obscure fringe cases, creating a solve. And I also want to thank Dynatron for getting back to me. Their message wasn't anything special, but the fact that they reached back out, told me to look into some things, check fan speed, stuff like that. I really appreciate it. It's good to have a company that can respond like that, A, and B, I think, I sent it to them at like 9 o'clock on a Saturday, and I think, Monday at 8 a.m. it was responded to. So they've got great support. Again, they're catering more toward the commercial marketplace, so you'd expect that kind of thing from them, and they're delivering. So they build an awesome product. It's like this case, it's very niche, but they're huge in the server thing. So this is probably not necessarily their bread and butter as Alienware builds. So I guess with all of this said here and done, we'll get back into the original video so you can kind of see some of the issues. But if this was what you're going for, how do I get my computer running better? Then the Dynatron K-21 cooler plus this Noctua, relocate your fans, you're going to be on a lot better situation in terms of noise and thermals than you were. So let's get back into the rest of the video here that showed that without this, those fans are equal. Hi, and welcome to another episode of Harrison Hobbies. Today we are going to be making yet another video about a very obscure application of a CPU cooler, and that is finding an air-only alternative, non-AIO, non-water block, non-liquid version of cooler for the Alienware series of computer. So the specific issue with this one specifically being the R8, I think it goes down to R6 and all the way up to, I believe, R13, the R14, the new ones, the new special edition ones with like the polycarbonate panels and stuff have relocated the CPU. But for the majority of generations of these Alienwares, as well as the Dell XPSs up until I think this year, as well as the Dell Precisions and the Dell Optiplex, all of those put the power supply up against right where the CPU was. And so that leaves you around 2.5-ish inches to fit a CPU cooler. I'll link a video to the original where I'd upgraded the CPU in here from an i5 to an i7. And we went through some testing, talked about some dimensions, but long story short, it leaves you about 2U, if you're talking server rack height, 2U of clearance. And so trying to find a 2U CPU cooler that fits in that has been a challenge. So Dynatron recently has released the K-21 CPU cooler here. It's based on the K555. The major difference between this and the K555 is the K555 has a smaller fan. I think it caps out at 5,000 RPM and it does roughly 25 CFM. And its rated TDP is around 95 watts. The new K21 here is, it's a bit upgraded. It's got a faster fan, so the fan goes up to 8,000 RPM. It moves around 45 CFM, so almost double. And then the last piece there is it theoretically should be able to cool up to 125 watts, at least their webpage says. In my journey, you know, I've tried some other CPUs. You know, I ordered the Dell. We can open this up here. The Dell cooler here. This one was specifically for, I think, the XPS and the Precision use these. It's a blower style, right? So your thermal plates down here. It's got a big AVC blower on it, and then the fans here, and it kind of mounts in, I guess, this orientation here. And most of these computers have, you know, your fan right up here at the top. And so the idea here would be that this just exhausts straight up. So tried this with the off chance that it would actually work. The Alienwares have some pretty hefty VRM cooling up at the top of the case where this shroud, or I guess your fin stack here is. And so that interfered. I didn't want to get rid of the VRM cooling, so I figured let's try something else. So after the OEM Dell cooler didn't work, I've still kind of been on the hunt, and that's when I came across the K-21 here. So the entire thing that kind of spawned this was, you know, at the beginning of the year I got into Chia, started plotting a lot. Having the 9th gen i7 with only 8 cores, no hyper-threading there, it was struggling to plot Chia, right? It was running 100%, and I mean, the thing was thermal throttling. And so, but you know, I figured, okay, maybe I can offload onto more cores and then downclock a little bit. So I upgraded to a 9900 KF, right? So the i9 with hyperthreading, so it's got 16 cores and it's unlocked and without graphics. So all of those things mean that it would probably be, it's the absolute best that you can get on the on this model of motherboard here, the 9th gen. So basically, as a result of that, you know, the little 95 watt cooler couldn't handle it even with a mild overclock. That thing was thermal throttling. I've been playing New World a little bit, and it will sit there at 100 degrees nonstop and just constantly thermal throttle. So hoping that we can try this out, we'll compare the K21 to the K555. We'll look for any differences there, and we'll see about getting this in. We'll run some benchmarks before and after, and so we can see if there's a head-to-head difference. So let's dig in. So I've zoomed in. We're going to run our first benchmark here on Cinebench R23. We have the 9900 KF in the machine as we discussed a second ago. Okay, so we can kind of see what we're doing here. We'll have Cinebench here. We have Alienware Command Center so we can monitor our temperatures. And then we have CPU so we can see kind of what each core is doing here. I'm not going to get into any kind of actual CPU temp logging. This should be enough here. So basically, with our CPU at a 4% load, we were running 38 degrees Celsius on the CPU, but we'll do multi-core. We're not doing any kind of stress test or anything. We're just going to do one. We'll see what it goes down to, and I'll kind of read out this in case you have trouble seeing it on the camera. Starting now. There we go. So it's already jumped up to 82. 89, 92, I guess these thermocouples are kind of connected here. So 97, 45%, 48, still climbing. So we're at 99C, and we are already thermal throttling down to 85, 81, 80, 78. So again, not a very strong overclock here. $79, so it's climbing. I think we've thermally soaked the block, so it should climb up a little bit here. Maybe it's not going to. We'll find out. Okay, we now have a rating here of 10,647. Also important to note is the CPU thermal paste that I have on here is the same stuff that comes with the Dynatron stock. We have it set in under Fusion here. We have an overclock profile 2, which should be the most extreme. And let's see what happens. Hopefully it doesn't end up shutting down this time. So we're running 100C now. So this looks, or sorry, that was 100%. We're running, for some reason we're not crossing over 4 gigahertz, and I'm not sure what's going on with that. But now we can see we're holding here at 99. We got 73% fan speed, and you probably can hear that it is significantly louder. And we hit 100C. So we've dropped down to 3.86 gigahertz, 3.9, 4.1, so it's really kind of pigging off the rev limiter there. And holding on to 4.02, 4 gigahertz here. Again, we're pegged at 100. And 73% fan speed. And now our turbo boost duration in theory is kind of ended here, and we're dropping down to 94. We're still holding pretty heavy. Okay, so when it doesn't peg off the rev limiter like that, you actually get better performance. We just ran this now, and we're at 9,488, so we're not even hitting 10,000 here. So hopefully this new cooler will kind of help with that. So let's shut it down. We'll pull the old cooler, we'll get some video of that, and then we'll install the new cooler here, and we'll do a quick kind of comparison about the features of each. So let's pop the cover here. Unlock, make sure both are unlocked, pop the cover, and put the side panel aside. Lift this guy here. Okay, and so here is our original Dynatron. There we go. Okay, so here is our original cooler here. This is the K666. And let's pull out the K-21 and check them out. So they look virtually identical. And, you know, probably a good alternative to this would have been just buying a better fan for this. But here are two Dynatrons. They're basically identical, right? Both have triple heat pipe setup. Both have, you know, spring-loaded screws. Both have you know, slightly proud aluminum base plate here. They both have, you know, similar fin stack. They both have copper fins on the bottom, and you can kind of see through slightly. Both of them have the heat pipes terminating at the top. All three of them go all the way through, and really, there's absolutely no difference that I can tell here. In terms of weight, even though they're not on a scale, we can actually grab a scale. But you know, they're basically identical, and I would argue that the only reason that I know that this is the old one is because A, it's warm, B, it has my thermal paste versus this one here that has my fingerprint now. But I don't even see a difference in fan profile at all. Same wires, not loomed or anything. You know, I mean, these are exactly the same construction on everything that I can tell. Even, you know, your brake line here where that's folded in versus this piece gets folded inward versus this piece gets folded down here. Same construction there. But let's grab a scale real quick and we can get some weight measurement. So first one here, this is the new K-21, and it weighs 18.11 ounces, and the old one here weighs, touched it again, darn it, so 18.03. So, I mean, we can just chalk that up to the fact that, you know, the fins may have been cut differently here or something. There's no major difference in weight here. I mean, that's just rounding error in material. So, I guess we've concluded now that the K-21 is physically identical to the K666. And I know briefly I'd talked about the same thermal paste. So the stuff that Dynatron uses and that I've started using is Shin-Etsu the Micro C, and it's a much pastier paste than something like you'd find in an Arctic Silver or anything that comes with, Cryo Rig, for example. And while we have this open here, we might as well at least just see, we can kind of show in case anybody sees this cooler and they're like, oh man, I'd like to have that OEM Dell cooler in my Alienware. In this one here, in this orientation, it would go, I guess I was wrong, my memory didn't serve me on what, and so it's this VRM here, not the VRM at the top. But this is kind of the orientation that it would sit in, and then it would blow hot air directly up into this exhaust fan up here. So, but as you can see, it's hovering above, and so the actual screws are right here. So again, just having that, the big VRM heatsink right there prevents this from fitting. Curious would ask, couldn't you technically remove that and, install it there? And short answer is sure. Yeah, definitely. But I haven't. But, okay, we'll take our smudged thermal paste here in our cooler, and then we will orient it. Again, this is a push configuration here, so air comes in here. We want it to exhaust out the top, so we will put it in this orientation here. Make sure that we're getting as much cool air as possible. Because again, these Alienwares actually have pretty decent airflow, albeit very loud. Again, the nice thing about the Shin-Etsu thermal paste is the fact that because it's a lot more viscous, we can say. Viscous is probably still an understatement for what that is. It's very much a paste. But you should typically, you don't apply a dollop and then go from there. You need to make sure you coat. And so, the advantage of that is you're a little less beholden to, your X pattern here to make sure that you get a nice even push to get that out, because, it's a paste. It doesn't flow very well. So whatever you've got on there applied, whenever you put your heatsink down, it kind of stays. But there we go. We're all buttoned up here. We'll take our power cable and then put it back into our CPU fan, and should be good. So again, if you've seen the other video, you should remember that whenever this closes here, we have very, very little room to play with. But we got that now, and then we'll take side panel here, push down a little bit to get it to fall into its tracks, and then there we go, and then slide it in, and then push that lever here closed, and we're done. So we'll put it back up over here and start it up and see what it does. So we're running 42 degrees, 11% CPU, and we're still in the same overclock setting. So we'll go back to temperature here so we can kind of look at this. We're at 10% fan speed. So I think we're probably stable enough here. So let's hit start and see what happens. So, and if we recall from last time, we were running probably high 9,000 up to around 10,000. Here we're at 85, 88. We seem to be climbing a little bit slower. So that's certainly some good news. 49, 50%, so we're still at 99. I don't have any instrumentation down here to measure decibel level. We could have gotten a TAC and we could have been measuring that actual fan speed, but I didn't necessarily want to turn this into that much of a science experiment. We're still hitting 100 C, so all I can say for this here is it appears that the K-21 really is a K666. I don't even know that the fan has actually changed at all. I don't know if anything else has changed. I mean, weights are practically the same, and it shows right here, audibly there's really no difference. It says that it should be able to handle an extra, 30 watts, right? 95 to 125 watt. And I assume that we're probably right around that many watts here. And here we went again, we got 10,497. Holding pretty much at 100 degrees. It's now 96. So it'll be interesting to see what the score is here. 9,991. So I guess $45 in, we have a K-21 and we have a K666 CPU cooler. There appears to be no physical difference between them. In terms of performance here, identical. Some things that could theoretically be happening here is because these use spring pressure to hold stuff down instead of a physical clamp like some of the other brands, theoretically the chance that maybe there's not enough clamping pressure to create a good interface between. If that's the case, then Dynatron theoretically hasn't calibrated their springs correctly. Past experiments, I've tried some Cryotech or CryoRig thermal paste. I've tried Arctic Silver. I've tried some other brands I couldn't even tell you off the top of my head. But all of them have similar characteristics here. So effectively what I'm trying to say is, you know, my hope to be able to use a Dynatron cooler in this machine, because personally I think they're the coolest looking. You know, I don't like the gamery aesthetic of internal components. Cases are fine, but I like to have that balance even though you can't see it. I still know it's in there. So it doesn't look like there is really any effect here. So I guess, you know, a couple of other solutions could be using a different low profile cooler, something for like a micro ITX build. On those, typically, again, those aren't really necessarily built for this kind of wattage. But yeah, after all the testing here, I mean, the pure solution would be get over my fear of water cooling and go with that. I mean, that is really probably going to be the only way to actually get any kind of real thermal performance out of this. But again, you know, something as small as this Dynatron cooler being able to handle a KF, you know, a 9900 KF is still, it's good, you know, for 90% of applications. You know, even when gaming on New World, if you're in town or something, you'll hear it go and you'll see it peak up to 100 and it'll stay there for quite a while. But in most day-to-day use, the CPU really isn't that bad. The Alienwares just are notoriously loud, period. So I think going forward, probably in a couple of months here, I want to build an Intel Extreme Series build. There's a quick comparison. We got to learn the K-21 is basically the same. I am going to email Dynatron and tell them, I guess, what I found. You know, identical weights, no perceivable difference, no difference in cooling by any means. And so if they respond back to me quickly and I have time to get it into the video, I will include what they said. If not, I'll have it in the comments. But as always, please like, subscribe, comment if you have any questions on anything, if you want some further clarifications, if you have any ideas for why the system may not work, or if you have any specific experience with the Dynatron equipment. Again, I know this is a very, very obscure video. It's a very, very obscure topic that probably, you know, aside from the IT realm, most people probably don't even use Dynatron. So I guess probably the 1,000 people that will watch this video over the life of it, please comment if you have any ideas what's going on here. So, as always, thanks for watching, and check back soon for more videos.